Refraction of light. In the refraction, there are two mediums. In the figure one is air, another is water. Incident ray, blue color ray, falls on separating surface of air and water at an angle I, that is angle of incidence of incident ray with norm, and the refracted ray goes to another medium, water. Angle of refraction is with normal of the refracted ray, and it is bending towards norm. Almost 1 or 2% light get back reflected in air. Our topic is refraction, that is from one medium to another. Therefore, we are not discussing the dotted portion of the ray, reflected light in air. Now let us come to the diagram second. Ray of light is coming from denser medium, glass, to the rarer medium, air. Blue color ray is incident ray. It makes angle of incidence I with the normal and goes away from normal. That is, the refracted ray makes more angle with normal. The third column, A, B, C are the three diagrams. Diagram 1, the incident ray comes in the direction of normal, falls normally on the separating surface from M1 medium 1 to the M2 medium 2. There is change in velocity from V1 to V2, but deviation means bending of ray is not there. Angle of incidence I with the normal 0 because it is in the direction of normal. Angle of refraction R is also 0 in the direction of normal. That is also 0. I equal to R equal to 0. Diagram B. The ray of light is coming from medium 1 with velocity V1. Angle of incidence I. In the second medium, in M2, its velocity changes, becomes V2 with angle of refraction R, and it is going away from normal. That is, angle of incidence I is less than angle of incidence R. It means second medium M2 is a rarer medium, just like the diagram 2 when the ray is coming from glass to air. In the diagram C, angle of incidence I in the second medium M2, angle of refraction R in the medium. First M1, velocity changes V2 to V1. Angle I is greater than angle R. It means ray of light is bending towards normal. That is, ray of light is coming from rarer medium to denser medium. Now let us come to refraction applications. There are examples of refraction. First one is eyeglasses. We are observing objects from the glasses, and these are the lenses through which light passes from air to glass and again air. That is, there are two mediums. Second, prisms. Prisms are made of glass. The ray of light coming from air goes to glass. That is refraction of light. Third is rainbow. In the rainbow, ray of light comes from air, passes through tiny droplets of water, and there is refraction. On the second diagram, there is water in a glass beaker. and a spoon is placed inside it. This water container is placed on a reflecting surface so that upper part and lower part both are observed here. The spoon is appearing here bending virtually, means not really, due to refraction of light. In the diagram 3, there is again water in a container, transparent glass container, and the pencil appears bending due to refraction of light. In the fourth diagram, pencil appears again bending due to refraction of light. And diagram 5, there is a glass slab. The ray of light is incidenting from air to glass and passing through air again. This glass slab is showing here refraction of light, and the red color ray at the last is the emergent ray, inside glass refracted ray, and in air coming to the glass slab incident ray. This is a laser light application showing here refraction of light. Now let us come to definition of refraction. When a ray of light passes from one medium to another medium, it bends toward or moves away from normal. This phenomena is known as refraction of light. In the refraction of light, number 1, speed of light changes. This is also the cause of refraction. Second, wavelength of the light changes, intensity of the light changes, but frequency of incident light remains unchanged after passing through the another medium. That is, frequency of light remains unchanged in other medium. Here is again, we are having refraction from air to glass, and in the second diagram, this application is also shown when the ray of light is coming from glass to air. Then we are observing two refractive index of the medium. So the refractive index is the ratio of the speed of light in one medium to the speed of light in other medium. Here N1 and N2 are the two refractive index of the two mediums. N2 is greater than N1, means refractive index of glass shown in the shading color, and air is white, that is, air of white color is outside in the both sides of the glass slab. Ray of light is shown coming from glass to air. Then angle of refraction increases. In the third diagram, ray of light coming from air passes through the glass slab and coming from glass slab. Now there are three rays. Incident ray falls on the glass slab, that is separating surface of air and glass. Next is refracted ray inside glass slab, and third one is emergent ray coming from the glass slab. Incident ray makes an angle with normal, that is angle of incidence. Refracted ray inside the glass slab makes an angle with normal, that is angle of refraction. And then finally the emergent ray makes an angle with normal, that is angle of emergence. Nearby it, here is another normal incident ray passes directly from air to glass to air without any deviation or bending. Last diagram is reflection through a prism. The red color ray falls from air on the separating surface of air and glass. Glass is a denser medium, air is a rarer medium, where light bends towards normal and the reflected ray inside the glass prism falls on the separating surface again and passes to air on the glass. The last medium is air, that is rarer medium. Glass is denser medium, therefore ray of light moves away from Earth. There are two laws of refraction. One is incident ray, reflected ray, and normal lie in the same plane. And second is Snell's law, the ratio of sine of angle of incidence I to the sine of angle of refraction R is constant. It is written as n is equal to sine I or sine divided by sine R, or we can take here theta angle, theta I or theta R, where one angle is angle of incidence, second is angle of reflection, and n is refractive index of second medium with respect to first. Snell's law can be written like it also. 1 and 2, meaning is refractive index of second medium 2 with respect to first medium term, that is equal to n2 divided by n1 is equal to v1 upon v2, and angle of incidence theta 1 is here, angle of incidence theta 2, therefore it is sine theta 1 divided by sine theta 2. We can write in another form, if I and R are the angle of incidence, angle of refraction, then sin I upon sin R is equal to V1 upon V2. Frequency remains unchanged from one medium to another medium. Therefore, there is change in wavelength, and this ratio is equal to lambda 1 upon lambda 2 based on the formula V is equal to n lambda, or velocity is equal to frequency multiplied wavelength. Now let us come to third diagram. N is equal to C upon V. This is known as absolute refractive index. Word absolute is coming if there is one medium air, another medium so glass, air, or any other medium, means with respect to air, at least one medium is air, then word absolute is coming. C is the speed of light in air or vacuum, and value is also 3 multiplied 10 power 8 meter per second. Last diagram is again N is equal to C upon V, that is refractive index, that is known as also absolute refractive index, is equal to velocity of light in vacuum C divided by velocity of light in medium V. Now let us understand the meaning A and W. Last word is W, means water refractive index with respect to air. W and A. A is the last word, that is refractive index of air with respect to water. N1, N2, and 3. Absolute refractive index. Absolute word is coming with respect to air. 1 and 2, there are two medium. The one is glass, another is water, or any other two medium, then word is coming relative. Relative refractive index 1 and 2 is equal to N2 upon N1. If one medium is here, then n is equal to c upon v, absolute refractive index. We have discussed that now. Let us come to the n to 1. N to 1 is another way to write it. Say 1 and 2 in the diagram 1. Meaning is same n to 1. Written in NCERT book also. N to 1 means refractive index of second medium with respect to first is equal to sin I upon sin R is equal to V1 upon V2. V1 velocity in first medium, V2 velocity in second medium. Diagram is also given nearby. Angle of incidence I, angle of refraction R in medium 1 and 2 respectively. Now n to 1, this is 1 upon n1 2. N to 1 meaning is refractive index of second medium with respect to first, and n1 2 meaning is refractive index of first medium with respect to second medium. This is known as reversibility of light. Now let us come to lateral displacement. In the glass slab, incident ray is coming from air to glass and refracted ray inside the glass and coming to air, and here is refraction. Now let us discuss the glass slab. Incident ray falls on glass slab made of glass, and medium 1, the rarer medium, medium 2, denser medium is bent towards normal, and the refracted ray passes to air again. That is, emergent ray becomes in air and both becomes parallel. That is, emergent ray, direction of incident ray are parallel. Perpendicular distance in them is known as lateral displacement. Let us define lateral displacement. The perpendicular distance between direction of incident ray and emergent ray is known as lateral displacement. Factors affecting lateral displacement: on increasing refractive index, lateral displacement increases. Number 2, on increasing thickness of glass, lateral displacement increases. Number 3, on increasing angle of incidence, lateral displacement increases. Number 4, on increasing wavelength, lateral displacement increases. Apparent depth is less than real depth. In the reflection of light, water is inside a container and there is fish at the bottom AB. Ray of light comes from air and passes from water to air. Then rarer medium is outside, denser to rarer medium, and in the backward direction, image of A is formed at A dash, that is, a virtual image is formed at A dash. Similarly, image of point B, that is virtual image, is formed at B dash, and these two A dash B dash make the complete virtual image in between the various points of reflection between A dash and B dash, that is the fifth which appears. Now let us come to another bending of light, that is, moon is appearing bending virtually, not really. Pencil is also appearing virtually due to reflection of light. Refractive index is equal to real depth upon apparent depth. Real depth is more, apparent depth is less. If ray is coming from rarer medium to denser, apparent depth is less than real depth due to refraction of light from one medium to another medium. Here is a glass made glass containing water. A coin is placed at the bottom. It appears raised up. Upper image is virtual image, that is apparent depth is measured from coin to the surface of water, and in absence of water, the real distance is measured from coin to the surface of water. Class diagram. We are observing a fish inside water. The real position is at the bottom, but appearing position is above it. That is not the real due to refraction of light. The rays coming from the object fish from water to air moves away from normal and in the backward direction. These dotted rays makes the virtual image in water. When we are observing here, air and water, fish is not appeared in the actual position. That is, apparent position is observed, which is dotted 1, due to refraction of